A few other kinds of identities, we call them sum and difference identities. The words sum and difference refer to the argument of your unique function on the left-hand side of the formula. So we have here sine of the sum of two angles, and then it has this expansion. And then we're going to be able to use this equality, this identity, to help us calculate trigonometric ratios for angles that we don't have in the unit circle. But when we add them up, we might see one of the unit circle angles. So for example, 15 and 15. So if I add them up, I get 30, right? Let's say 10 and 35. I don't know individually what sine of 10 is or sine of 35 is, but if I plug them into the formula, I would have sine of 45, which I know from the unit circle what it is. So these identities help us utilize the unit circle for angles that they're not in the unit circle, or let's say not in the unit circle, they're not the ones that we memorized in the unit circle, right? We only memorize values for 30 degrees, 45 degrees, 60 degrees, and the quadrantal angles. And of course, in radians, it's the same thing. So why use the above identities? What I just said, if I have, I just explained this part. So if I want to do sine of 10 times cosine of 20, I can't do. It's cosine of 10, sine of 10, I can't do. But I recognize being sine, cos, cosine. Sine, cos, cosine with a positive in between it, it will be sine of a plus b. So I would do sine of 10 degrees plus 20 degrees, because that's the left-hand side of the formula. It's the first one in the list, which then I know that is sine of 30 degrees, which I know now it's 1/2, because I know I memorized them from the unit circle. So this is going or using the formula from the right-hand side towards the left. So we were given the right-hand side, and then we utilized the left-hand side to be able to calculate the expression value. The other kinds of identities or questions from the identities is calculate sine of 75 degrees. You don't know this one because we haven't memorized a value for this kind of angle, right, for sine. So then you have to think about two known angles in the unit circle that when we add them up is 75 degrees. That's your first thing you have to do. So what are two angles that we know? 30 and 45. And then we have then sine of 30 plus 45. This is a question I get a lot. How do I know it's sum or difference? Because you're the one that chooses the angles. So if you say 75 is made of 30 plus 45, then it's a sign of a sum, because that's how you get 75. And then this is not going to be sine of 30 plus sine of 45. That's not how the identity works. You have to use the identity. What the sign of a sum means? It means take the sine of the first angle, so sine of 30, times it by the cosine of the second angle, so cosine of 45, like that, plus the cosine of the first angle times the sine of the second angle. Now for every single one of these, just get a value. Sine of 30 is 1/2. Cosine of 45, square root of 2 over 2. Plus, cosine of 30 is square root of 3 over 2. Times sine of 45, square root of 2 over 2. And then here we can have a multiplication. We're going to multiply square root of 2 over 4 plus square root of 6 over 4, and then you put it together into one fraction, square root of 2 plus square root of 6 divided by 4. That's pretty much all our lesson 2, basically, but we're going to do some more complex questions as well. But just variations of using these identities. Okay, so let's start with just simplification using sum and difference identities. So just rewriting an expression in simpler terms. So write the following expression in terms of cosine function only. It's worded. So I think the difficulty, again, it comes from the wording of the questions. They sometimes mean, or they want you to do the same thing, but the wording can be different. It may say simplify this expression. It may say something like this, write it in terms of cosine only. What your job is going to be is to go to the Rolodex of all the information from this unit and say, okay, what do I see on the page? Well, I see sign of a difference. What do I know to do to sign of a difference? Okay, don't do sine of theta minus sine of pi over 2, because that's wrong. That's not how this applies. You have a formula that allows you to open up that bracket. You can't open up the bracket with distribution because it's not sine times that bracket. It's sine of that bracket. The only way you can open that up to individually tackle those angles is using the identity that's called sine of difference. So grab your identity formula, and what does that say? Sine of A minus B. Sheet on it. The formula, she says alpha and beta, A, B, X, Y, doesn't matter. Okay, so sine of theta minus pi over 2, this would be your A, this is going to be your B angle. Sine of alpha minus beta means sine of the first angle, so sine of alpha times cosine of the second angle, cosine of beta, minus cos of alpha times sine of beta. Okay, so we have to do sine of theta times cosine of pi over 2 minus cosine of theta times sine of pi over 2. For sine of theta and cos of theta, you're stuck. You can't evaluate that with more information. Okay, the only way you could evaluate and get another value for it if you have some x, y, r, but we don't have anything like that. So you're stuck with that one. But for cosine of pi over 2 and sine of pi over 2, you can find the value. And we know that at quadrantal angles, our values oscillate between 0, 1, -1, right? So we're hoping that with those zeros and ones and negative ones, something will cancel out. And I'm going to get to something in terms of cosine only. What I will usually do is draw a sketch of my angles. That's where pi over 2 is. And I'm going to put my point there. So I have the 0, 1. And I'm going to remember that on the unit circle, the points are represented in the order of cosine of theta and sine of theta. So cosine of pi over 2 is 0. Sine of theta in front of it, it won't even matter anymore because I'm going to multiply by 0, right? Minus cos of theta from before. And sine of pi over 2 is 1. So sine of theta times 0, that gives you 0. Minus cos of theta times 1 is just itself, so cos of theta. So our final answer is just negative cos of theta. Is this in terms of cosine function only? Yes, it is. Yeah? It's not cosine only? It is, right? That's what it wants. It just wants you to write the expression. It doesn't have sine, doesn't have tangent, it doesn't have cosecant, only has cosine only. So as long as your final answer is only using cosine in its expression, then you're good. And of course, you haven't made any errors. Simplify the following expressions. So we have cosine of x plus pi over 6 plus sine of x minus pi over 3. I want you to erase that 0 equals 0. We're just going to look at it from the perspective of just a given expression. It will equal 0. We'll show that, but yeah, let's consider it like that. So we have a cosine of a sum, and then we have sine of a difference. If you want, you can split the work in 2 separate steps. And then at the end, make sure you put them together, because in between them, you have plus, right? You have to add them up. So let's start with the first one. Cosine of the first angle plus another angle means cos of the first times cos of the second minus sine of the first, sine of the second. So cos x times cos of pi over 6. If here you have plus, with the cosine of sums and difference, it's always opposite sign in the expansion. You'll have minus here. And then you have sine of x cos of pi over 6. So we're going to be working with pi over 6 and pi over 3. I would do my 1, 2, 3s here. 1, 2, 3. 1, 2, 3. This is where pi over 6 is. This is where pi over 3 is. So continue on. Cosine of x times cosine of pi over 6, so square root of 3 over 2, minus sine of x, cosine, oh, I missed it, this is sine, not cosine, sine of pi over 6, so 1/2. Nothing to cancel out here, right? So cos times square root of 3 over 2. We can definitely go further if you want. Like you can do square root of 3 cos of x over 2 minus sine of x over 2. And then you can put them together if you want, but it's not going to help us, okay? So there's no point. I wouldn't even go there, okay? I would wait for my third step and see if anything cancels up as a group, okay? So leave it alone. Go to number 2. Sine of x minus pi over 3. This is sine of the difference. Sine cos minus cosine. That's the pattern. Sine of x, cos of pi over 3. The sign will match here. Cos of x, sine of pi over 3.
Cos pi over 3 coming
From here,
yeah.
from the formulas. So if you're doing a sine of a difference, this is your alpha, that's your beta.
Yeah.
Sign of a difference means sine of the first times cosine of the second minus cos of the first, okay? They're never just distributions. They're always going to be these expansions. So if you want to use the angles inside a sum or a difference, you have to expand it using the sum and difference identities. Okay? It's like you have to look at the mic formulas. Okay, that's what it is. Of course, there's yeah.
Sink it all in and look at the page and then go back and forth here.
Should I go a little slower? Is it too fast? Yeah. Okay, slow me down. Okay, are you all caught up? Okay, so everybody clear now where those values are coming from and how to use the formulas? Okay, so we are given the left-hand side, right? So we're given the sign of a difference, sign of a difference. So we're replacing that with the right-hand side expansion, right? Just like we've done in the previous lesson, we're just sort of using the identities in different ways to prove something. Here, the goal is to simplify, right? Okay, so we replace this with the right-hand side of the identity, right? And now we're gonna replace anything that we can evaluate with the value of them. We can't evaluate sine of x, we can't evaluate cosine of x. So we're gonna leave it alone. Cosine of pi over 3 cosine is 1/2 minus cos of x, sine of pi over 3, square root of 3 over 2. Now what we're going to do is, for number 1 and 2, we're going to add them up, because that's what it says, add them up. So we notice that we have a square root of 3 over 2 times cosine here, that's a positive, but then we have a negative square root of 3 over 2 times a cos. So that's going to give you a 0 there when you add them up, right? Does that make sense? They cancel out, so equals 0. And then you have a negative 1/2 sine of x, and here you have a positive 1/2 sine of x. Right? So the whole term, they're opposite of each other, so these terms also cancel out. And then that means the whole thing, when you add them up, equals to what? 0, right? So equals 0. Now I could write that, since you're asking me to go slower, you can just watch this, you don't have to. I could have written it like this. Cos of x square root of 3 over 2 minus sine of x 1/2. And then I have to add it to sine of x 1/2 minus cos of x square root of 3 over 2, right? Because then you see it a bit better, right? So this one cancels with that one, this one cancels with that one, so equal to 0. Right? So it's really up to you, as long as you can see what are the like terms and what are the not like terms that can lead into your expression. So back to our box with the sum and difference identities. Any kind of equality or identity will have a left-hand side and a right-hand side. And what we did last class and continue on this class is, if I'm given the left-hand side, but I want to use the right-hand side, I can just replace it, right, with the other one, because that's what equality means, right? I mean, they're equal. Same thing with the sum and difference. So if I'm given something like this and I need to work with it, okay, well, I can't do sine times alpha, sine times beta. That doesn't work. The sine of something. It's not sine times that, right? So they're stuck. The only way you can go from here to something else is to use the identity on the right-hand side. That means the whole thing is gone and you replace it with the other side, right? Now, where are these angles coming from on the other side? From here, right? It's the same thing, A and B, alpha, beta. Make sense? Now, sometimes you have to work from the left-hand side to the right-hand side. Sometimes you have to go from the right-hand side to the left-hand side. It's depending on the question, depending on the needs. Same thing right here. Sometimes I'm given cotangent and I have to replace it with 1/10. Sometimes I'm given 1/10, I have to go to cotangent. It doesn't really matter, right, which way you go. Or sometimes I just need to go from cotangent to that, right? So it's all depending on the question needs, right? And you're the one that decides what you're going to do. Let's keep going. Okay, this one was just simplifying, so just plainly using the formulas to go from one form to another, very similar to proofs. And I think today we will have some proofs too at some point. Let's go to example 3, which is sort of the introduction that I gave you at the beginning of the lesson to tell you why we need the identities, is these types of questions where you're asked to find the exact value of a certain function. Now, you heard about this question over and over in the previous unit, right? Find exact value, right? But we were asked to do that using the unit circle directly with the angles we have seen, or in the same family of angles with a reference angle. Now, in these types of questions, you don't have that. So the angle 1/5 is not in the family of angles in the unit circle that we have memorized. So then what you have to do is think, can I find two angles that give me 1/5, and those two angles are recognizable in the unit circle, or two angles that subtract that give me 1/5, that again, they're recognizable in the unit circle. It can be either or. It can be any pair that either adds or subtracts, because we have sum and difference identities. Right? If you can find those two angles, then you can use those identities to get you to the final answer without a calculator. Because obviously, I can take my calculator, right, and plug in sine of 1/5, and it's going to give me an answer, right, in a decimal format. But I need an answer in exact form, right, from the unit circle. So fractions, whole numbers. Okay, so what are two angles that add up to 1/5 or subtract to 1/5? 60 degrees and 45 degrees. And I am using degrees at the beginning because I know it's difficult, okay? If I go straight to radians, it's a little bit harder. So that means I can rewrite sine of 105 as sine, because these two added together are 1/5, as 60 degrees plus 45 degrees. And no, it doesn't matter in which order. Yes, your expansion will look a little bit different, but in the end, your final answer will be the same. So now you say, okay, it's sine of a sum, right? Of an addition. What do? You go to your formula sheet and say, okay, I have sine of a sum. What's the expansion? That one. Sine of the first times cosine of the second plus cosine of the first, sine of the second. So what I like to do sometimes is do this. After you do a lot of these ones, you find your own way of dealing with them. I do this: sine, cos, sine. So I memorize the pattern. And then you do the first angle, the second angle, the first angle, the second angle. There's the 60 and 45. Now we're going to evaluate. That evaluates with, or 2, square root of 3/2. Cosine of 45 evaluates to square root of 2/2. Cos of 60 degrees is 1/2. Sine of 45 degrees is square root of 2/2. Square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. 1 times square root of 2 is square root of 2. 2 times 2 is 4. They already have the same denominator. 4 at the bottom, square root of 6 plus square root of 2 at the top. Sorry, because it doesn't work. Because you can, if you ever wonder how the rules work, take a rule for yourself and see if actually it's true, right? So take something that maybe you know how to evaluate. Square root of 4 plus square root of 9. You know this is 2, and you know that's 3. So it should equal to 5, right? Is that the same thing as saying square root of 13? Does that still equal to 5? Right? Because then you say, okay, it's square root of 4 plus 9, right? Does that make sense? That should equal. Then if it doesn't work for something like this, that's very simple to evaluate individually, right? And to check to see your formula or your rule, then it won't work for other ones that you cannot evaluate either. So the rule for square roots, when you add them and subtract them, you cannot put them together under the same square root. But for times, you can. Okay, for times and for dividing, you can. So for here, when we did square root of 3 times square root of 2, that is allowed to be square root of 3 times 2 under the square root. Okay. Clear? Okay. So our final answer for example 3. Okay, find the exact value of cosine of pi over 12. You already have the solution here. You know, I like to write, so I'm going to explain and write. You can watch. There is your relaxation point, right? Just to watch. Maybe watch me, Greg, not the phone. How about that? Thanks. Okay. Side note. Okay. So find the exact value of cosine of pi over 12. Now, with radians, it's going to be a little bit more difficult to find the two that add up to this angle that is not in the unit circle, but your given ones, the ones you find are on the unit circle. So I'll give you some, I guess, tools to use. The first thing I would do is split this pi over 12 into 2 fractions over 12. That's the way you have to do the backwards calculation. You wouldn't be able to add 2 angles unless they have the same denominator, or subtract the same way, right? Now, the next thing you do, because something over 12 is not on the unit circle, you have to find your terms for pi, something for pi here, such way that it will cancel with 12. So it will be one of the factors of 12. So 3s, 8s, 4s, 2s, anything like that, okay? So combinations of those numbers, so that I will get 1 pi over 12. Okay, so for this one, because I have to get 1, it might have to be a subtraction, right? So what pi over 12 minus what pi over 12 can give me 1 pi over 12? And it can be trial and error for the first few times you're doing this work. 3 and 4, but in the other way, right? 4 and 3, right? So 4 and 3. Now, these are great choices for numbers because 4 does simplify with 12, right? And 3 does simplify with 12. Does it subtract to 1 pi over 12? Yes, it does. Now I can simplify because I can't work with these ones in these forms. I have to make sure they will give me an angle on the unit circle. So if I cancel 4 with 12, I'm getting 1 pi over 3. And if I cancel 3 with 12, I'm getting 1 pi over 4. So both pi over 3 and pi over 4 are on the unit circle. So I can use these angles in the expansion of the cosine of the difference. So cosine of pi over 12 is cosine of pi over 3 minus pi over 4. Because pi over 3 minus pi over 4 equals pi over 12. So if I go backwards, I'll get this. Make sense? Yes? So far we are at this step, right? When we found here 60 and 45, we found pi over 3 and pi over 4 with the subtraction in between, right? So we are at that stage. This is going to be your alpha, that's going to be your beta. And now you're going to expand. You need cosine of the difference of two angles. So you need cosine of alpha minus beta. So you have to use that side. Cosine pattern is cos, cos, sine, sine. This is how I do it. Cos, cos, sine, sine. And then the sign here, if it's subtraction in between here, it's going to be opposite. So it's going to be plus. And then the first angle, the second angle. First angle, the second angle. So I've done it really quickly. I applied that formula in here with the angles that we found. Now, one by one, evaluate. Now, careful, this is so common, such a common mistake. It bothers me. I don't know why it bothers me so much, but I see this. Cosine of pi over 3. What's the evaluation of that? We've done it already today, right? Pi over 3, cosine 1/2, right? I see cos 1/2. Is that correct? No, because this whole thing equals the 1/2. So what's the cos doing here? Okay, you're not doing cosine inverse, right? So you shouldn't have cos there anymore. It's a very common mistake. I see it all the time, okay? So cosine of pi over 4, that's square root of 2 over 2, plus in the middle, sine of pi over 3, square root of 3 over 2, sine of pi over 4 is square root of 2 over 2. Square root of 2 over 4 plus square root of 6 over 4. So square root of 2 plus square root of 6 over 4. Done? It's over here as well. So you okay, the solution? Yeah, you'll notice that a lot of these answers are pretty much the same. Same like with the unit circle for your family. Sorry? Is it? Maybe. I don't think so. It might be from the same family of angles, right? In a different quadrant, right? So it's just like that's what I wanted to say. It's just like the unit circle for our family of angles. You had the same answer for sine in quadrant 1 and quadrant 2, right? Because it's the same point, equivalent, just different sign for the x coordinate, right? So it will be the same absolute value, but maybe a little bit different, right? So you'll see a lot of combinations of these numbers, these fractions, okay? Square root of 6, square root of 2, and over 4. So, yeah, you will see the pattern. Nothing's like a lot of patterns, right? Not everything's a pattern, but some patterns for sure. Okay, example 5. So now we're going from the right-hand side of those expansions towards the left-hand side. So you're having the same question, find the exact value. But now you're given the right-hand side. So you see sine, cos, sine with a plus in the middle. You got to recognize that pattern of sine, cosine, or cos, sine, sine. Because this is the right-hand side of these formulas, right? For cos and sine addition and subtraction. And then you also recognize that if you were to do this question without the calculator, because the question says exact value, you are stuck because angles 20 and angles 25, it's not an angle. We memorize values on the unit circle. And we also notice the same angles repeat on the other side. It has to be, right? The same angle there, the same angle there. Now, which formula would this be? Sine, cos, cosine with a plus in the middle. Sine, cos, cosine with a plus in the middle. It's the right-hand side of this first expression. That means I can replace it with sine of alpha plus beta. But my alpha is 20 degrees and my beta is 25 degrees, which makes it sine of what angle? 20 plus 25. 45. Do I know what sine of 45 degrees is? Yes, so we are done. These are amazing. Same thing. Cosine 48, cos of 18 plus sine 48, sine of 18. Now we have cos, sine, sine with a plus in the middle. The angles are the same. There's our alpha. There's our beta. That means we can use the right-hand side, take us to the left-hand side of which one? The first one, the second, the third, the fourth. The fourth one, yes. Then we have cosine of alpha minus beta. So 48 degrees minus 18 degrees. Which is cosine of 30 degrees, which I already again know what it is. Cosine of 30 is root 3 over 2. Sorry. But there isn't anymore because see, this is the equality that we used, right? And this is what's given to us. So this was the 48, that's the 18, that's the 48, that's the 18. So because you have it equal to this, the whole thing here, it's not needed anymore. We just replace this with 48 and that's with 18, and that's what we're gonna use now. Because this, the right-hand side is not useful to us because I don't know what cos of 18 or cos of 48 is. So I'm done with it. So I have to use something else, okay? But if I replace it with the left-hand side, which we did, then it takes us to cos of 30 degrees, which I know what it is. It just says that this cos of 30 degrees equals that, right? So either I use this with my calculator, because I could, right? Or I use this without the calculator, I'm gonna get the same value. And we can check if you want. Let's do it just for fun. I'm gonna make my mode in degree, it's already there in degree. And then if we do cos of 48 times cos of 18 plus sine of 48 times sine of 18. We're getting 0.8666. So let's see what square root of 3 over 2 equals to. Divided by 2. The same thing. Okay. So it just gets you to the same answer, but without the calculator. And you're using the parts of the equality that you need. Go ahead.
That sheet that you keep referring to is a copy, so.
Yeah, of course. There's extras always in that bin. Purple bin, I think the second or the third slot.
Thank you.
You're welcome. Okay, so now moving on to the last one, I think, with exact values, and then make sure you try all the your turns because it gives you extra practice, more like skill practice than extra, it's more advanced. So we're doing the tangent. This is the first tangent we're doing. They're the same thing like the cosine and sines. Tangent of, so you have angle pi over 18, that's your alpha, and angle pi over 9, that's your beta, and then you have 1 minus tangent of those exactly the same angles. This is the key part there, they have to be the same angles. So now we have to identify which one of the tangent formulas is this expression. Is it the fifth or the sixth? The fifth one, because it has 1 minus at the bottom and plus in between, right? The sixth one has minus at the top and plus at the bottom. So we are using the contraction of tangent of the sum. So alpha plus beta. Now, which one is alpha? Pi over 18 plus, which one is beta? Pi over 9. Tangent of, now I have two fractions that have different denominators. I need them to be the same denominator, which is 18. That means here I have to multiply by 2. So I would have pi plus 2 pi at the top there. And then pi plus 2 pi is how many pies? 3 pies. That makes me think of pumpkin pie. Yes, you had some, yeah. I have 4 or 5 pumpkins that I grew this summer that are waiting for me to make some pie with them. We can cancel 3 and 18, 1 and 6. So that makes us 2, or takes us to tangent of pi over 6, which gives us what value? Root 3 over 3.
Is that just the top part of that, or this, the bottom part of that?
No, because remember, we said this is what's given to us,
Right.
right? So I can't use that. I'm going to use only that. It simplifies the question quite a bit, right? Yeah. Mhm.
And if on the bottom of your, these are switch, I'm saying it was 1 minus 10 pi over 9, and then 10 pi over 18.
That's a great question. I'll be okay because it's still multiplication, right? So then it's commutative. You basically could put them in the right place, then match the formula, and that'll be okay. Mhm. You need a break? Yeah, let's take a short break. Until 4:05. Let me see how much we have still left. Example 6. This is the last one of the day. So yeah, take about 10 minutes break now. 4:10 is okay. Example 6, an XYR question. The first one, it's already done on this page, and the cosecant of alpha plus beta is on the next page. Okay, so if sine of alpha is -3/5 and tangent of alpha is less than 0 or negative, then cosine of beta is -5/13 and tangent of beta is positive. Find cosine of alpha plus beta. Cosine of alpha plus beta. Now, when I see what's asked of me, cosine of an addition, I know that the only way to find that is basically expand it, right? Because I can't just say cosine of alpha plus cosine of beta. That's not a true equality, right? So the only thing I can expand to something that maybe is going to allow me to do something with this expression is by applying the cosine of the sum. So that's going to be cos of alpha, cos of beta, minus sine of alpha, sine of beta. And when I do so, we recognize that I know what sine of alpha is. Sine of alpha is, so this one is no, I have it as -3/5. And I know what cosine of beta is. This one here is -5/13. What I don't know is cosine of the same angle, like this guy here, sine of alpha, and I don't know what sine of beta is. So these questions are very similar to the ones that we've done in Unit 4, but this time you have two different angles that are part of the question, right? In Unit 4, you only had one angle, and you asked to find the value of another function for that same angle. Here you have two angles, okay? So for that reason, this is still an XYR question. You're still gonna have to tackle it like that, but you have to do it for two angles. So let's split it up into angle alpha and angle beta like that. Now let's see what information I have about angle alpha. I know that sine of alpha is -3/5, meaning that the angle alpha, knowing that the value is negative, it has to be somewhere in quadrant 3 or quadrant 4, right? Now, this is going to make me have two values for whatever other function I have to calculate. So is there more information that's going to narrow down where my angle is? Yes, there is. We also know that tangent of alpha is less than 0. This just means negative. Now, what is tangent negative in which quadrants? 2 and 4. Meaning now, with these two pieces of information about the same angle, I know that the alpha angle is in quadrant 4. Okay, so I narrow down where the angle is. And I need that so I know the sign at the very end of the new function. Now, sine of a function, we have formulas for it. That's y/r. Okay, we need to find what x is, right? These are, again, x, y, r types of questions. So let's find x. X squared plus y squared equals r squared. X is what I'm looking for. Y is 3 squared. R is 5 squared. It's up to you if you want to include the sign or not. It doesn't matter because when you square it, it's going to become positive, right? So it's going to be gone. X squared equals 25 minus 9, which is 16. Square root everything. X is positive, -4. We'll decide based on the function value. So I'm given sine of alpha, so I know it. What I need to have for this expansion is cosine of alpha, right? So we're going to calculate the cosine of alpha. Cos of alpha, the formula is x/r. X is 4, r is 5. And in quadrant 4, cosine values are positive. So that's going to be one that's going to be used now in here. Cosine of alpha, right? So 4/5 found. This was given. This is given. Now I have one more to find. Now these two are together, right? Cos of beta is given. -5/13. It's a different angle, so you have to do it again twice. And then you analyze the sign. The cosines are negative in quadrant 3 and 2. That's right. And then we also know from the givens of the question that tangent of the same angle, tangent of beta, is positive. So tangent is positive in which quadrant? One and three, therefore, angle beta is in which quadrant? Three. They're the same, right? It cannot be in one or two because it doesn't work for both of these pieces of information. Back to XYR. Cos is X over R. That means we need Y. X squared plus Y squared equals R squared. 5 squared plus Y squared equals 13 squared. Y squared is 169 minus 25, which 144. So Y equals plus minus 12. So we were given cosine of beta. We're trying to find sine of beta, right? So sine of beta equals Y over R. Y is 12, R is 13. We are in quadrant 3. So positive or negative for sine values? Negative in quadrant 3. So that's what we're going to put into here. Now, once you have a value for each, using the x, y, r for each of the angles, you just have to multiply through and see what it reduces to. So you would have 4 times negative 5, that's negative 20, 5 times 13, that's 65. So negative 20 divided by 65, and then you have negative times a negative times a negative. That makes it a negative. 3 times 12, that's 36 over 65. So it just makes it negative 56 over 65. Clear? Can you see unit 4 somewhere along the question? A little bit? Okay. I hope so. We're gonna do one more. This one is not given to you. Cosecant of alpha plus beta. Now, cosecant is the reciprocal of which function? Of sine. Okay, so we don't have formulas for the reciprocal functions in terms of sum and difference. So whatever sum and difference you have of the reciprocal functions, all you gotta do is 1 over the same. Because this is just still an angle, right? If let's say angle theta is alpha plus beta, I could just replace it with another angle, whichever the sum it is, right? So just because I'm writing an angle as a sum, it doesn't mean it's not actual an angle there, okay? So it's 1 over sine of alpha plus beta. So all I would have to do is expand sine of alpha plus beta, get to an exact value, and at the very end, I have to remember that I have the reciprocal of that value. Okay, so sine of alpha plus beta, expansion looks like this. Sine, cos, sine, alpha, beta, and then plus in the middle. You just take this one from the formula sheet, okay? You don't have to memorize anything, just make sure you know how to find it. Now we're using the same givens for this question, but let's pretend it's just new givens, okay? So I would say, okay, what do I know? I know sine of alpha. So that's negative 3 over 5. So I know that. And I know cosine of beta, which is negative 5 over 13. So I would need the other two. this is the information that I have for one function value, and I need to find another function value for the same angle. That's what we've done in unit 4, right? Given one function value, find another one using x, y, r, right? The other one, the cosine of beta value, you have to use to find the other function value for the same angle, sine of beta. Again, x, y, r. So when you're doing your work, you have to do it separately for alpha and for beta, but the process is exactly the same. Okay, it's not different. Same thing. So you say sine of alpha is -3/5. Again, this is exactly the same thing because we're not using different givens. But it's okay to be the same thing because it's going to help you cement that flow of writing. So sine values are negative in quadrant 3, in quadrant 4. We also know that tangent of the alpha is negative, which means, again, this is true for quadrants 2 and 4, meaning that I know now where the angle alpha is in quadrant 4. So you always have to find a way to figure out what quadrant your angle is. If you don't, then you have to show 2 answers because I don't know in which quadrant it is, right? So either or this one, I don't know. And then from the actual value and the formula for sine, which is y over r, we're going to find the missing piece, which is x, using the circle equation. So x squared plus y squared equals r squared. X squared plus 3 squared equals 5 squared. X squared equals 25 minus 9 equals 16. X is plus minus 4. Again, we have done this. Now, what do I need for the blue part? I need the cosine of alpha, right? I had the sine, I need the cosine of the same angle. Cosine of alpha is x over r 4/5 in quadrant 4. We say cosine values are positive. So done. 4/5 in that spot. Now you have to repeat the XYR process for the angle beta. For this one, we're going to skip because it takes us a little too long, but you understand what we have to do, right? The same thing, it's already done on the previous page. So cosine of beta equals -5/13. This is X, that's R, find Y, identify the quadrant, all the way, find the Y value, which was 12, right? The previous question, right? It's the same thing because the same givens. It's the same question, right? It's just we're asking a different question, but we're using the same values. The we need sine of beta, which is 12/13. We are in quadrant 3, right? We were in quadrant 3. So negative. So we have -13, 12/13. Now let's plug in and calculate. We have -3 times -5, which is positive 15. 5 times 13, 65. So 15/65. And then we have positive times a negative, which is -4 times 12, 48/65. So far, so good? 15 minus 45 or 45 minus 15? How much? 33 over 65. Now remember now you have to remember what this is. This is just sine of alpha plus beta. We found it's negative 33 over 65. The question wasn't about sine, cosecant. So that's the difficulty, not difficulty, but the most common error is to forget to flip it over at the end. So cosecant of alpha plus beta is going to be the flipped over version of this. So negative 65 over 33. You can leave it as superimposed fraction, or you can just write it as a mixed fraction. It's up to you. Done. We have another version of this question, and it's your turn. And next class, we have partials and three. I think we're gonna gauge it the way we're gonna see how it works, okay?